Hello, hi students. Let us see another problem based on Euclid division lemma. The question is, use Euclid's division lemma to show that the cube of any positive integer is either of the form 9m, 9m plus 1 or 9m plus 8 for some integer m. So dear students, this question we have taken from exercise 1.1 from real numbers chapter, question number 5. The question is, as you see, that we should use Euclid division lemma to show that the cube, here it is given cube of any positive integer is either of the form 9m or 9m plus 1 or 9m plus 8 for some integer m. As per the previous question, we can take the positive integer as x. Let x be any positive integer and it is of the form 3m. Instead of m, we can take as per the previous note of question number 4, we can take as the same. So 3q or 3q plus 1 or 3q plus 2. We can take like that. So why we have taken here a divisor as 3? Why we didn't take 9? The answer for this question is we have to do a cube of a number. So here I have taken 1 cube, 2 cube and 3 cube. If you see that 1 cube is 1, 2 cube is 8 and 3 cube is 27. Among these three numbers, 27 is divisible by 9. So it is enough to take 3 cube. Another reason is, if you take 3 as divisor, only we have 3 forms of numbers, and so that it is only enough to take 3 cases. Whereas if you take 9 as divisor, there are 9 forms and we have to take 9 cases. It leads to the more complication towards our problem. So it is enough to take this one, 3m or 3m plus 1, 3m plus 2, this format. Instead of m, we have to prove in the question 9m, m we have to use in question. So we are taking another variable q in the place of a quotient. So first case 1, we are taking that x is equal to 3q. So we have to cube it. So we should do it x cube. So cube on both sides. 3q, you have to cube it. When you cube 3 cube is 27. Cube we get it. From this one we can split this as 27 as 9 into 3 cube. Instead of this number we can substitute m. So 9, we get 9m, where m is equal to 3q cube. Now case 2. Case 2, we are taking x is equal to 3q plus 1. So cube on both sides. So 3q plus 1 whole cube. Now a plus b whole cube formula. So I have written here for your so you can recall that formula. We should use it. So a plus b whole cube identity we are using. So that is a cube plus 3a square b plus 3ab square plus b cube. So that we apply here. So we get x cube is equal to 3q whole cube plus 3 into a cube means 3q whole square into 1 plus 3 into 3q into 1 square plus b cube is 1 cube. So when you cube it, x cube is equal to 27 q cube. Then we multiply this one. Here when we square it, 3 square is 9 and q square is q square. So 9 we have 9 into 3 again 27. 9 into 3 27 q square plus again you multiply these two numbers. 3 threes are 9 into 1. So 3 threes are 9 into q. So 9q plus 1. So x cube is equal to, from these three terms, we can take 9 outside as common because these three are multiples of 9. So when you take 9 outside, we get 3 nines are 27. 3 nines are 27. So 3q cube plus the same way 3q square plus 9, 1q. So 1q plus 1. So instead of what is in the bracket, we can write as m. So x cube is equal to 9m plus 1, where m is equal to 3q cube plus 3q square plus q. So now we got the form 9m plus 1 here. Next we write the case 3. Third case we are writing. Here we are taking x 3q plus 2. So we can cube on both sides. X cube is equal to 3q plus 2 the whole cube. So again we can expand using a plus b whole cube formula, that is 3q whole cube plus 3 into 3q square into 2 plus 3 into 3q plus 2 square plus 2 cube. So now x cube is equal to, we can cube this number. So 3 cube is 27 q cube plus here 3 square is 9. 9 into 3 27 into 4 into 2, that is 54 q square. So 9 square is 3 square is 9 into 3 27 into 2 54 q square plus here 2 square is 4, 3 3s are 9, 9 into 4 36 q plus 2 cube. 2 cube is what? 8. Now from these three terms, now we can take 9 as common outside. So when you take 9 outside from this, from 27 q cube, we can take 9 outside. So 3 9s are 27 q cube plus here 6 9s are 54 q square plus 9 4s are 9 4s are 36 q plus so that's all we have taken plus 8. Now what is in a bracket we can write as m plus 8. So where what is the value of m? Where m is equal to 3q cube plus 6q square plus 6q. You may have a doubt how the m can have this value, because q, we have said the q is some integer. So where q is some integer, so we are having 3 6 and 9, we are multiplying with the q cube and q square and with q. So finally we get a integer number here. So this integer number we can equate to m. Hence, the cube of any positive integer is either of the form 9m or 9m plus 1 or 9m plus 8. So we only got that answer 9m plus 8, 9m plus 1 and 9m. Hope you understood. Thank you for watching.